center of the particle. For example, that's why I want to lift it. I want to lift it or rotate it. I rotate it, or you can take in the ceiling fan or the table fan. Anything you have to take. So where the force is applied to the thing, to the any body, any ceiling fan or a table fan, you can take ceiling fan itself. Okay. Now we go for ceiling fan where the force is applied. Center of the particle. So anywhere the particle is, if you take, what it will be, you have to apply the force towards the center of the things. So the main center, so that's why it's called a center of gravity. So in the center of gravity, if it tells that, so similarly now we go for momentum of inertia. So the momentum of inertia is that, so the rotational, the kinetic energy, the momentum of inertia nothing but the kinetic energy of the rotating body. That is, what is the kinetic energy of the translational motion? Linear motion or translational motion? Half mv square. Why you blinking for this? What is kinetic energy? Half mv square for the particle that moving in the linear direction or translation motion. Now we are going for the momentum of inertia. So the momentum of inertia, what is it? Then what is momentum of inertia? Now what? No, I don't. What is now? What do you mean by momentum of inertia? Momentum of inertia, kinetic energy, the kinetic energy for the translation motion. Now momentum of inertia for the rotational motion. So the kinetic energy which how we got half mv square. Now we go for here, which is I omega square, where I is the, so moment of inertia K is equal to half I omega square. I is the mass, omega is the angular displacement, angular velocity. So the angular velocity is angular velocity. So I omega square. I is current? No, I is not a current. Momentum of inertia is equal to what is half mv square. That's why I asked you what is kinetic energy of the linear motion. Total kinetic energy is equal to half mv square. What is m? M is the mass, v is the velocity. Here it is I is equal to I omega square. What is I here? Omega. What is omega? Omega is the angular velocity. I is the mass with respect to angular rotation. I is the mass or momentum of inertia. So total energy I is equal to kinetic energy is equal to I omega square. Of I omega square. Okay, so I is the momentum of inertia, omega is the angular velocity. So now difference between linear motion and rotational motion. Okay, displacement we will tell as here x. Here we will tell as the theta, angular displacement. So in linear motion we will tell displacement as a x. Here we will tell as a theta, which is angular displacement. Then we go for velocity. How we will tell? We will tell velocity v. V. So what is v is equal to? Velocity is equal to what is the displacement? Okay, displacement is time. What notion we give, just now we gave for angular displacement. Just now I gave for linear motion. What is the displacement I give? For linear motion, displacement I gave us x. So velocity v is equal to now. Velocity v. What is velocity now? Velocity is equal to dx by dt. That's all. Just now I gave the displacement. Linear. Whatever you can give, whatever, it's not x, y, z, a, b, c, d, e, f, g, h, anything you can give. Now I gave the notation. So what notation I gave, you have to change according to that. For for velocity it is v is denoted by dx by dt. Now angular, then acceleration will give by, acceleration is equal to alpha. Alpha is equal to alpha is equal to dv by dt or you tell me now. dv by x alpha is equal to dv by dt. Why dv by dt? Change of velocity with respect to time or equal to what? Or equal to what? Alpha is equal to, which is acceleration, is equal to dv by dt. Acceleration is equal to rate of change of velocity divided by time, is equal to rate of change of twice the velocity, that is d square x divided by dt square. You are aware of this or not? D square x by dt square, that is the differentiation of velocity. Okay, what is acceleration? What is acceleration? Acceleration is equal to dv by dt. Okay, d by dt you take outside. Just what is velocity now? Dx by dt. Substitute that value here. Instead of velocity, you substitute the dx by dt. So d by dt into dx by dt. So what you will get now? Dx square d square x by dt square. That's all. Then mass is given by m. Then force is equal to mass into acceleration. No, this you need not write. It's I gave in the last book itself. Just you can reason, that's sufficient. Okay, mass m, force is equal to mass into acceleration. Then work done is equal to force into distance. What is force here? F, work done is w. W is equal to, what is the force? F. F I already know. Force is denoted by F into work done is equal to force into distance. W is equal to what? Work done is equal to force into distance. Okay, work done, not force. Force is equal to what is force? Force is equal to m into a. What is m and what is a? Acceleration. Now work done is equal to force into distance is equal to what? What is force? How will you denote force? Force you denote by F. Distance you denote by D. X. What notation I gave just now for the distance x? See, with respect to that only we are discussing. Distance is x. Velocity is equal to v. V is equal to dx by dt. Then acceleration. Acceleration is alpha. Alpha is equal to dv by dt or is equal to dx square by dt square. Dx square d square x by dt square. So like that. Then again what is the given? Force is equal to mass into acceleration. Then work done is equal to force into distance. Force is F. Distance is x. X. That's x is only I gave there. Then kinetic energy is half mv square. Okay. Then power is equal to force into velocity. Force into velocity. Power is equal to force into velocity. And linear momentum is equal to mass into velocity. So in the same rotation we go for angular velocity. Rotational motion. The rotational motion angular displacement is theta. You need not write, just listen is sufficient. It's there in the notes are given. Just listen, you listen, that's sufficient. Angular velocity, angular displacement is theta. Okay. Then angular velocity is omega. Omega is equal to d theta by dt. The same rotation, just for rotational versus linear versus rotational. That's all. So theta, angular displacement is theta. Then angular velocity is equal to omega. Angular velocity omega is equal to d theta by dt. Okay. Why d theta by dt? Because rate of change of velocity with the rate of change of displacement with respect to time. So that is omega. Omega is equal to d theta by dt, and angular acceleration alpha is equal to d omega by dt. Okay, d omega by dt or equal to dash equal to d square dt square. Yeah, d square theta divided by dt square. Moment of mass here we refer as m, but here we are referring as momentum of inertia, which is I. Then here we are referring as a force. Force is equal to m into a. Here we are referring is as a torque. Torque is equal to momentum of inertia into torque is equal to I into a. I into alpha. This is similar to alpha. Alpha both is acceleration. For linear acceleration, we are taking this alpha. What is linear acceleration? Alpha is equal to
dv by
dt. Here it is angular acceleration, that also we are denoting by alpha. Alpha is equal to, for angular acceleration, alpha is equal to d omega by dt. D omega by dt, here it is dv by dt. So now torque is equal to I into alpha. Then work done, here it is F into x. Here it is torque into theta. Torque into work done is what is work done here? F into what is F? F is a force, x is the distance. Here you come. Torque is equal to what is force here? Torque. So torque into m, no. Torque into what you will get? Distance. What is distance here in rotational motion? Theta, yeah, t. So torque into theta, that's all. Then kinetic energy is equal to half mv square. Half mv square. Here I will tell for linear, you have to tell for rotational. Half mv square. Here it should be half into
omega I square. I omega square. Half I omega square.
No.
Yes, sir.
Here it is half mv square. Okay? Did you understand what I am asking?
Yes.
Okay? Here it is half mv square. Okay, here it is half.
Omega square.
No, somebody had to say. Okay, you tell. You understand now? Huh? You understand? In linear motion it is half mv square. Here I am coming for rotational motion. So for rotational motion what it is? Huh? Half into? No, I can't hear you. No, wait. What she's telling, I can't hear you. You have to speak loudly. See, I am speaking loudly, right? Everybody, people from 100 people can hear my voice. 100 people who's sitting at the back row of 100 students will be there. They can hear my voice. No need for mic, nothing. But you are telling something, I can't hear you. What she's telling? I can't hear you. What she's told? What she told? Of I omega square. So what is I and what is omega? What is I? What is I? What is omega? What is mass? What we are discussing for linear motion versus rotational motion we are discussing. For linear motion it is half mv square. Okay, I will give the value of mv square. What is I m here? What is v here in linear motion? M is the mass, v is the velocity. Now I am coming here. It's a rotational motion. Rotational motion is what? What is the kinetic energy now? What is kinetic energy? No, wait. I am talking to her. Because I have to assess whether everybody have understood or not. That's why I keep on asking the various person. Okay? So now I am coming for kinetic energy of the kinetic energy of the rotational motion. What is the kinetic energy? What is kinetic energy? Huh? What is kinetic energy of the rotational motion? I already gave the kinetic energy for the linear motion. What is the kinetic energy for the rotational motion? Of I omega square. What is I? What is omega? What is I? What is I? That's why I keep on asking others. What is Y? Just now I explained you. What is I? What is omega? I given you everything part by part. Huh? I is not the mass. Just wait. I am talking to that. Just now I told you. Just now I am talking to her. I am discussing with her. I told you I need to know everybody has understood or not. That's why suddenly I will ask somebody. Because if you are not listening something like that, suddenly I can catch. Because I can identify from the face itself whether we understood or not. Okay? That's why what is I now? I and omega. I is not the mass. I is not the mass. Just now I explained to you everything. It's a linear motion versus rotational motion. I is the momentum of inertia. Omega is the angular displacement. No, omega is the angular velocity. So I is kinetic energy is equal to I omega square. I is the momentum of inertia. Omega is the angular velocity. That is half into momentum of inertia into angular velocity square. That's all. This is the kinetic energy of the rotational motion. For linear motion, it is k is equal to half mv square, which is half into mass into velocity. That's all. I am explaining everything. If you didn't understand immediately, you can tell me that I didn't understand. Again, I will repeat it. Repeat once again. Okay? Then I will go for work done. Now work done. Work done here it is force into displacement. Now I am coming here. Work done is equal to torque. No, work done is equal to W is equal to what? What is force here? Huh? Force. There is no force here. There work done is force into distance. So similar way, what is force here? Force. What is force here? What is distance here? Force. Mass is different from force. Mass and force are different. What is force here? What is force here? Torque. Torque into theta. Theta is the angular displacement. So force into distance, which is F into X. Here it is torque into theta. That's all. That's why I am teaching you step by step everything. I am teaching you everything step by step. Then it is power. Power is same. Power is force into velocity. Here it is torque into, because here I am coming here, power, same power. What is force here? Force here. There is no force in rotational motion. So what is the force here? What is force in the rotational motion? And what is velocity in the rotational motion? That's all. Force into velocity there means torque omega. Torque is the force here. Omega is the velocity, which is angular velocity. There it is linear velocity. Here it is angular velocity. That's all. Then linear momentum. Linear momentum is equal to mass into velocity. Here it is. Okay, at least you tell this. Mass into velocity. Now I am coming here. Now it is rotational motion. What it is now? Angular momentum. Angular momentum is denoted by L. So what it is now? Here it is, there it is, mass into velocity. Here it is. What? You understood or not? Angular linear momentum. Linear momentum is equal to mass into velocity. There. And now I am coming here. What is here? What is mass here? What is velocity here? Mass. What is mass here? What is mass here? No, I don't know from you. Okay. What is here? What is? What is momentum? Momentum is equal to mass into velocity. Okay. Now I am coming for angular momentum. Angular rotational motion. In rotational motion, what is mass? So rotational motion, in linear motion, it is mass into velocity. So I am coming here now for rotational motion. For rotational motion, what is mass into velocity? There mass into velocity. What is mass? What is velocity here? So that you can substitute that value. That's all. What is mass and what is velocity here? In rotational motion, not in the linear motion. You understood my question now? You understood the question. I am in linear motion. In linear momentum, P is equal to mass into velocity. Okay. Here it is. I am coming here in here angular momentum. Angular momentum is equal to mass. What is the mass and what is velocity here? I. What is I? Momentum of inertia. I is momentum of inertia. Then what is the next? What is velocity here? What is velocity here? Huh? Omega. That's all. I into omega, because I is the momentum of inertia. Here it is angular velocity. That's all. I into omega. So if you are not understood, you just tell me. I am not understood. I will explain once again. That's all.
Sir, angular velocity.
Angular. Angular velocity omega is equal to t theta by dt. No, you need it right. Linear velocity is dx by dt. dx dt. You need not write this. Everything is there in the notes. Everything is there. You need just listen. That's all. Listen. You are not understood the concept. Only you have to understood. Okay. See now where we left. Momentum of inertia. Of mv square. If you substitute v is equal to r omega. V is linear velocity. You can convert it into angular velocity, means v is equal to r omega. So if you substitute v is equal to r omega, so it will become r square omega square. So now what we can write, of into m into r square omega square.
Sir, is the equation for what, sir?
No, the substitution. Linear conversion of, see what is kinetic energy here? K is equal to half mv square. K is equal to half mv square. Now I am substituting v. What is v? What is v here? Linear velocity, not velocity. Linear velocity. Linear velocity are converted into angular velocity. So what I have to do? V is equal to r omega. R omega. So if I am substituting for r omega, what will happen? Half m into r square v square. That's all. Then theory of perpendicular and theory of parallel. Anything you can go to the fan blade itself. Fan is there. Blade, I told you, you are applying external current. I don't want to go to the current. Okay, I want to go to the current. What are the possibility that I can rotate? By rotation only. See, I am asking the question, you are asking. Okay. Fan is there. Okay. You just turn out. Turn off the switches. Turn off the switches. Turn off the switches. Take out the plug. Okay. I have to rotate the fan. What is the fan? Only for possibilities. I can rotate in my hand. What are the possibilities that I can rotate? Huh? No. From my hand, I have to rotate the fan. Apply to the force in which direction? Where you have to apply? To the center. But there is another possibility is there. Okay. Side also you can set it. Right? Yeah, is possibility there. No. You can remove that cover and just if I push the blade, it will rotate. So that rotation will not long for the long time. If I rotate it to the center only, if I apply more forces, what will happen? If I apply more forces, what will happen? The blade will rotate. Depend upon the force again. I cannot rotate for long time, but at least for 5 to 10 minutes I can rotate. But if I rotate to the blade, what will happen? Only it will rotate for a limit or not even limit, few seconds it will go, because it will not have that much force to run. But if I rotate it to the center, what will happen? By giving more force to rotate it, what will happen? The fan will rotate at least for 5 minutes or 10 minutes, something or so. Okay. So which direction I am applying? So which axis I am applying? Which direction to the? Which direction? That you can rotate clockwise, anti-clockwise. Story. Don't tell the story and all. Okay. Don't tell the story. Clockwise, anti-clockwise. If I rotate like clockwise, it will rotate in the clockwise. If I rotate in the opposite direction, it will rotate in the opposite direction. Which direction I am choosing it? No, which direction and all? Which direction? Which direction I am choosing it? I direction. Right direction, right, left. You never ask the question. No, you are telling all the possibilities one by one. Everybody are united. No, everybody is united because everybody taking one option. Everybody taking one option. So in that definitely one will be correct. So I have to go to that, right? So everybody united together. Which direction I am choosing? I am choosing the perpendicular direction. The perpendicular direction, that is I am choosing the x-axis, z-axis, let us assume I am choosing the z-axis. Then fan will rotate in the which plane? Which plane the fan will rotate if I choose x-axis? XY plane, XY plane. XY plane if I rotate, if it is XY plane, so I am choosing the x-axis. So I am going for y plane, x-axis means which plane will rotate? Obviously y is z. So if I choose z, y means it will go for XY plane. That's all. So this is the perpendicular direction. So whatever I have to choose, whatever the force I am giving, I am giving the which is perpendicular to it. The theorem of perpendicular tells that the total energy, so if I give any force, if I give what is if I give any force, the force in the force given in the x-axis, okay, no, y you can take. I am giving the force in the z-axis, okay, which is in the z-axis means the output you can expect in the x and y plane. So that is x-axis and y-axis. So the total force you are giving in the z-axis. So Fz is equal to Fz is equal to Fx plus Fy. That is your force that I am giving in the z-axis. You can expect the output of the force in the y and x and y axis. Then in parallel axis, in the if I same thing, now I given in the perpendicular direction. So something I have to give in the parallel direction. What is the thing you will choose now? Parallel. Fan is not one. Just now I explained you fan. And how will it rotate, which axis you will rotate, what is the output, everything. Did you understand this perpendicular direction? Then we'll go for parallel. Perpendicular means which direction the force you are applying, the output you can expect in the other two direction. That is perpendicular. So that is I am applying in the I am applying in the z-axis. Z-axis means the output of it you can expect in the y and z. The fan need not run for 1 hour or 2 hours. 3 hours, nothing like that. Just 5 to 10 minutes is sufficient. I am giving a strong force so that fan will rotate for 5 minutes. 5 minutes or 10 minutes you can just take it. That's all. So which direction I am applying it, you can expect in the opposite direction. Perpendicular direction, which is 90 degree. That is a perpendicular thing. Now I am applying in the parallel direction. What is the experiment I will take that I apply in the parallel direction?
On the blade.
You understand my question now? Parallel direction. What you will apply in the parallel direction? I have to apply the force in the parallel direction. No, parallel direction. Ball only, okay, that's 50% answer only. 100% answer. Ball. Taps. Rotational motion. I have to apply something. You might have played it here also. Yeah, it's right. What is it in English? In English? Marbles. Marbles. No. English. No, what you told? Before that.
Top, sir, top.
For that, what is it tell in English? Top. Top. So the top is the one that I apply for the parallel direction. I am applying the thing like this. I'm applying the force in the parallel direction, it will rotate it. So that's a parallel direction. So that's one of the example for the parallel direction. So that means you need not, only two possibilities there. Only you have to go for perpendicular or parallel, that's all. So whatever in the world, any rotational motion, that will come into this parallel and the rotational motion. It's a top, what is it? Top. What is the spelling? T-O? I think T-O-P-P, I think. Top. No, it's not a top, I think. It's not a spelling. So you try to find out what is the English meaning. Okay. You have to find out now who discovered current, AC, DC, which year. Then English meaning for this top. I think T-O-P-P-Z, I think, tops. It's not top, T-O-P, top. T-O-P-P-Z. Okay. T-O-P, no, I'm for this specifically they are having the names. So you have to find out, okay. So two things you have to find out, AC current, DC current, who discovered it, year and top. So the total force is equal to, total force in the which direction. For example, I am applying for Fx means, Fx means what? Force in the x axis. So the Fx is equal to Fx plus F. That means the force that I am applying and which direction it is. So Fx is equal to Fx plus Fx is equal to Fx plus F. So the total force that I am applying, what is F here and what is Fx here? Fx is the force that is applied in the x direction. So the total force that I applied in the x direction, Fx is equal to total force Fx that is applied plus total force that is applied, the plus F. And say similarly one more notation I will tell you. You have to tell for the angular for linear velocity, it is v is equal to v0 plus at. V is equal to v0 plus at. What is v here? B. B is the velocity. What is a here? T is the time. Now that's okay. Now you have to tell for angular rotational motion. Who wants to? No, any one person tell. Who is willing to tell? So I will give three equation you tell in the rotational motion. Okay. So what? Who will tell now? First, I will tell linear motion. You have to tell for rotational motion. What is for v is equal to v0 plus at? What is v here? B. What is v here? A is t is time. Yeah. Who now? Yeah. Write it and tell me. One by okay. I write this also. V is equal to v0 plus at. Okay. Then second one is x is equal to x0 plus v0 t plus of at square. X is equal to x0 plus v0 t plus of at square. Then v square is equal to v0 square plus 2ax. V square is equal to v. First one is I will repeat once again. V is equal to v0 plus at. First one. Second one is x is equal to x0 plus v0 t plus of at square. Third one is v square is equal to v0 square plus 2ax. That's all. Convert it into now rotational motion and tell me one by one. Yeah, I will tell one. Do you want to repeat once again?
No, sir.
This one.
No, sir.
Okay, I will repeat once again. V is equal to v0 plus at. Okay. X is equal to x0 plus v0 t plus of at square. V square is equal to v0 square plus 2ax. That's all.
What is V0, sir?
What is v0? What is v0? That you have to tell me. V0 is what? Yeah, correct. Velocity at 0. Velocity, initial velocity. Velocity at 0 is initial velocity. Because final velocity will vary. Initial velocity will not vary. That is 0. That is. Now we convert it. Did you convert it? Did you convert it? It will take 1 second, that's all. 5 seconds, 30 seconds, that's all. That's all over. Okay, who tell the first one? No, I will ask one by one. Who will tell now first one? Who will tell the first one? That's all. Just 30 seconds, 1 minute, that's all. 20 second, 20 second, 20 second.
Omega equal to.
Wait. Omega is equal to?
Omega 0 plus alpha t.
Alpha t. Correct. That's all over. First is over. Second. Who will tell the second one? Who will tell the second one?
Omega 0 plus alpha t.
Who will tell the second one? That's all over. Who will tell the second? Over. That's all over.
Theta equal to theta 0 plus omega 0 t plus of alpha t square.
Okay. Second also over. That's all over. That's all over. Now third one. That's all over. Time is over.
Omega square.
Wait. Who will tell? Okay, tell.
Omega square is equal to omega 0 to omega square 0 plus 2 alpha t 0
No, 2 alpha 0 theta. Theta. Oh, that's all over. It should not take not more than 1 minute. That's all. So now. Yeah, so work done is equal to omega work done is equal to F into x. F into x in the linear motion. In rotational motion it is
torque into theta.
Torque into theta. So I am having the n torque. What will happen now? N torque.
N torque into theta.
N torque means torque 1, torque 2 up to torque n into theta. So the force is equal to mass into acceleration. That's all over. Don't write that one. That one is over. No, you should not take more than 1 minute. That's all. So just linear conversion to rotational conversion. That's all. Torque is equal for force is equal to mass into acceleration. Torque is equal to I into alpha. This we discussed. No, this we discussed. Then you might have played a small game in your childhood. No, you can rotate yourself. You can. You can rotate yourself, right? Did you? No, not that rotation. In your fixed point, when you are fixed in a fixed point, you can rotate about yourself. Okay?
Yes, sir.
So that
Example.
No, that's what I'm telling. What is the game name? I forgot that game.
Dance, ballet.
No, it's not a dance. It's not a dance. Okay, fine. Anything. Okay, so that force that was everybody can try, right? I think they'll try. You might have rotated in your childhood everything. A childhood something like the rotation. So when you able to rotate it, okay, when you able to rotate it, where you have to put your hand?
Center.
In the center or anywhere you can play. So at the time, what will the head and hand angle will be? Perpendicular. So when you put that perpendicular rotation, what will happen? The rotation will be faster. So the rotation should be faster. So that is the input that we have input. What is the output? We are giving the force to the outer side. So then the rotation will be faster. Okay. Now the kinetic energy of the rolling motion. The kinetic energy of the rolling motion has two kinetic energy. It has both kinetic energy. For example, I am taking one slanting table. You might have played in the game. In the park, in the park. In the park you might have played. You people. Slide rover. What is the name? Slide rover. Sliding rover something. Sliding rover. You have to claim the star. You have to claim the steps, something small steps. Then you have to sit there and you have to slide over there. So in this two possibility arises. Okay, I'm taking two possibility sliding arises. You go to claim the steps. I think steps and keep the rectangular box. Okay, keep the rectangular box. It will come down. Okay, when I keep top of it, it will come down to the bottom. Now again you keep the football. Okay, it will rotate. Then it will come down. So during the rotation, it has possesses the two types of energy. That is, it's a kinetic energy and rotational energy. Kinetic energy and rotational energy. So the kinetic energy is given by half mv square, and rotational energy is given by half I omega square. So the total values. So what is the value for omega? Just now we discussed omega. Omega is equal to V is equal to R omega. Now what you have to do is omega. What will you substitute now for omega? Omega. B is equal to R omega. Now omega is equal to V by R. V is equal to R omega. V is equal to R omega. So omega is equal to V by R. So now you have to substitute the omega value by V by R whole square. So now what I will get? Half mv square plus half I into V square by R. No, V square by R square. So since here also V square and here also V square common, you have to take V square outside. That's all. So K total energy is equal to half mv square plus K square plus R square. That's all. That means which is common here in both? Half mv square. Half mv square is common in both. Here also both common. So you have to take it outside. So you will get 1 plus K square by R square.